Hello students, I am Dr. Tanmoy Biswas. I welcome you all in my channel Chemistry, the Mystery of Molecules. Today's topic of discussion is on MCQ about reaction of cyclopropane derivative. So you can see the molecule here where there is actually a cyclopropane of 3-member ring. So it undergoes two-step reaction and produces a product, and you have to say what is the major product of this reaction. And by the way, after reading this problem, many of you have a question, sir, we are not familiar with this reagent or Burgess reagent. So what is this? For your easily understanding, so I have given this Burgess reagent structure. So I guess now you can find out that what is the answer. So I request you student, pause the video, try by yourself, and whatever answer you get, please write in the comment box, and don't hesitate whether your answer will be right or wrong, because self-evaluation is essential for improvement. And don't worry, after some time you will get the right answer. And by the way student, I have a request that for every video I request you please visit the description box of this video, because related video links will be provided there. Okay, so now let's go to the problem. So if you look at first step is Burgess reagent, just benzene 20 hour and heat, simple. And second step is 3% aqueous HCl THF-RT, and there is actually a ketal. Generally we say such rings as acetal, but it is a protected version of ketone, that's why it's called ketal. But no ketal is there, so you can understand the second step is hydrolysis of ketal. Now question, what this Burgess reagent does? If you find out this, your life became easier. So this Burgess reagent actually selective and mild dehydrating agent. So it removes water. So alcohol to water removal, then what is the product? Product is alkene. And in this case reaction is pretty mild. But what is the uniqueness of this reagent? Because generally for dehydration of alcohol we use acidic reagents, but that may produce carbocation which can undergo further rearrangement, etc., etc. Lots of reaction possible. Not only that, this acid sensitive groups like acetal may also get affected during this reaction. So that's why such mild reaction conditions are highly appreciated in synthetic chemistry. Now if you look at the reaction steps, so first Burgess reagent is responsible for dehydration, means it produces water, it removes water. Now in this case actually it removes water, I will not say produce, so it's a different complex reaction, I am not going that. So in the first step what happens, that these OH reacts with Burgess reagent and proton removal happen. And by the way, there are two sites where proton removal possible. One is from this hydrogen, actually I am saying this neighboring carbon attached hydrogen. Not only that, second is this proton. So in two places proton removal possible. Generally Burgess reagent preferred to result in more substituted alkene, which is a Z-shape product. But in this case relatively opposite is followed. Why? For example, if the double bond is produced in exocyclic to this single bond, then this double bond is not that much stable, because generally we say most substituted alkene is more stabilized, but in this case it may not be true 100%. Why? Because this double bond is exocyclic to this cyclopropane ring, and we know this double bond is actually sp2 hybridized, so bond angle here expected to be 120, but here it is not 120, it is closer to 60 like that. So that's why it is not that much stable. Consequently what happens? And another thing we know, cyclopropane bonds are little bent, banana bond, so it's not that much stable. And alternatively if you look at other option is there, means hydrogen here which got removed in this context. Now first step produces this alkene. An interesting part, if you look at the asymmetry of this center is maintained, and this is increased, this indicates the mildness of the reaction and stereoselectivity. It doesn't have this neighboring carbons, asymmetry is not affected, and this clearly proves that this reaction doesn't produce carbocation at this position, because when there is a carbocation production there is a chance of rearrangement, so it doesn't happen. Because this 3-member if migrates, string ring strain is expected to be released little bit, so that thing didn't happen. Now in the next step is 3% aqueous HCl THF-RT, so this is actually nothing but ketal hydrolysis. By the way, I have already discussed dedicated lecture on Burgess reagent and ketal. I shall provide the link in the description box. Now your main doubt, if you haven't read these Burgess reagents, are how this reagent works for alcohol dehydration. So for your brief understanding, first this OH attacks this sulfur center, and through acyl nucleophilic substitution type reaction, these quaternary ammonium part is leaved, because the leaving group is neutral in nature. And not only that, so in this way it produces an ester derivative. which undergo elimination. So the negative charge on this nitrogen, which is actually it's highly stabilized because this negative charge is in conjugation with this carbonyl and these two S double bond. So it's a significantly stabilized, but still it can act as a mild base. So it abstracts this proton, and all the reaction is via intramolecular pathway. So intramolecular pathway, through ring formation, it abstracts this proton and this bond comes here and it goes. So in this way alkene is produced. And remember, this negative charge on O minus is stabilized with the conjugation of this sulfur oxygen double bond. So this way alkene is produced. Now in this case, what is the product of this reaction? Obviously double bond in the tertiary center. So option C is the right answer, and in this case no asymmetry is lost. Now if this question appear on your exam less than 30 seconds, how can you come to the right answer? Frankly speaking, student, if you don't know anything about this reagent, Vargas reagent, it is very difficult to conclude. So in this case I do not have any tricks to say that this will be the product. So, and this second step is not that much valid because under acidic condition acetal will be hydrolysis and in 4 option there is no acetal. So only the problem's heart is this nature of this Vargas reagent. So from there you can conclude. If you know that it is a dehydrating agent, still you can combine that, okay, B or C, and B is relatively less stable because of this 3 membering, so there is a high chance that C will be the product. But for that purpose you need to know that Vargas reagent is a selective dehydrating agent of alcohol under milder condition. So now in conclusion, what you have learned today, that it's a mild and selective dehydrating agent. It can be successfully utilized for the preparation of alkene from the alcohol, and the conjugate amide anion, means that I have shown the negative charge on nitrogen which abstracted the proton and resulted in alkene, actually get more stabilized due to delocalization doubly, one with carbonyl and 2 sulfur oxygen double bonds. Now for this dehydration reaction no acid is required, and which is better for acid sensitive functional groups like acetal, and that's why you have seen that after the first step acetal was remain intact, and in the second step we have selectively deprotect the acetal, or here you should call it that ketal. Now double bond on the exocyclic position of cyclopropane is not very much stable because double bond means sp2 carbon, its angle is expected to be 120, but in case of cyclopropane this angle achievement is difficult, which result in angle strain. And finally, upon sp3 to sp2 hybridization there is a chances of asymmetry loss, but in this reaction it didn't happen because reaction is so selective and no carbocation is produced, so asymmetry was not destroyed. Now this is the reference where I have taken this problem. You may visit for better understanding. Now this is the end of discussion. I thanks everyone for watching. If you really enjoy my content, please help this channel to grow, and you may visit 2 of my another channel for further learning. So stay happy, stay blessed. See you in my next video. Bye bye.